Hey guys, just another quick video. This time dealing with the thermodynamics of inorganic compounds. This time we're gonna go and try to find the lattice energy of NaCl using the Borne-Haber cycle. Overall, it's pretty simple. So the first steps to go and solve this is to go and plan out the enthalpy of formation to form NaCl. So to form NaCl, we need to write our formula as Na, which is a solid, plus half chlorine this forms the NaCl we know. However, the energy to go and form this is actually found in our enthalpy of formation tables. NaCl is right here to negative 410. So around negative 411 kilojoules per mole has to be released in order to form NaCl. So the next step is the enthalpy of sublimation of sodium. This means we sublimate sodium solid into a gas, and the energy needed for that should be around 108. That can be found on our chart here. Sodium is 108 or around 109. We're just gonna go with 108 kilojoules per mole. The next step is we need to atomize our molecule of chlorine. And to do that, that should take around 121 kilojoules per mole of energy. I'm gonna write down our formula again. Chlorine. Now this 1/2 is very important here because to break a chlorine bond, usually it would take, looking at it right here, it's actually 243 kilojoules per mole of energy needed to go and break a Cl-Cl bond. However, this 1/2 impacts this number. So this 243 that we saw before, it's going to multiply by 1/2. This gives us 121 kilojoules per mole energy to go and break Cl2 into Cl. So that is atomization of chlorine. So the next step is the first ionization of sodium. Now we're going to see a big jump here because this is going to be a pretty large number. So to ionize sodium from its ground state into Na plus, into Na plus. If you check on our chart, it should take around sodium here. It should take around 502 kilojoules per mole. So we're just gonna add that here to the chart. We're just gonna put 502 kilojoules per mole. As Na plus gas plus chlorine gas. The actual equation for this, which you don't have to write down, but would be Na gas to form Na plus gas plus an electron. However, you don't need to write that down for this. The next step is the electron affinity of chlorine. So we're gonna make this line longer and drop it down because this number should be negative. Okay. So for electron affinity of chlorine, we look back at our chart and find chlorine here. Chlorine's electron affinity is negative 349. So negative 349 kilojoules per mole. And we write this equation as just Na plus gas plus Cl negative gas. This, we wouldn't go any further because NaCl if we look at their ions, like let's say in a solution, when Na is dissolved in water, they go into Na plus and Cl negative. We wouldn't have any more steps to add due to this cause. So the last part is lattice energy, which we're actually trying to solve. But how do we solve for the lattice energy? Well, the simplest trick is just to count backwards. So we're going to go up, down, 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 down. It's going to be a positive 349. When you go down, it's going to be negative 502. We're going down again, negative 121. Go down again, negative 108. And then when we go down again, it's going to be negative 411. This will give us our lattice energy. We'll put it into our calculator. We get, cut this part. We get 793 kilojoules per mole. Pretty simple.